Hi everyone, welcome to RIC If you are preparing for your chemistry board exam, this section is for you. Today I am giving you a simple smart scoring framework, 10 example hacks for organic chemistry. Don't skip this. Let's make organic chemistry more predictable because in the exam hall strategy decides your marks. For instance, if a numerical is given, always write the formula first. If it is an organic reaction, draw the structural formula first. If it is a reasoning based question, write the key concept or keywords such as resonance, inductive effect, hydrogen bonding, DD transition, unpaired electrons, etc. If it is a name reaction, follow NCRT exactly. And if you're confused, attempt the question. Never leave it blank. Write the closest concept or structure. So now let's move on. Hack number 1. If a reaction is given, first check is the carbon chain increasing. If yes, immediately think of Grignard reagent or potassium cyanide. Grignard reagent with aldehyde or ketone gives alcohol with an increased carbon chain, and with carbon dioxide gives carboxylic acid. Casein forms carboxylic acid after hydrolysis. Remember, casein increases the chain by one carbon only, while Grignard reagent can extend it further, even creating branch chains. Note, if chain doubling of alkyl halide occurs, think of the Woods reaction. So, always check the carbon count before solving. Hack number 2. Is strong base present? Now check, is it bulky? A bulky base favors E2 elimination. Alcoholic KH also favors elimination. Aqueous KH or an hydroxide ion favors substitution, especially in primary halides. Remember, bulky base, elimination. Small nucleophile, substitution. In Williamson synthesis, an alkoxide reacts with primary alkyl halide. It follows SN2 reaction, leading to ether formation. While with tertiary alkyl halide, elimination dominates, leading to the formation of alkenes. Thus, steric hindrance decides the pathway. Moving on to hack number 3. Is alkyl halide given? Check its degree first. Primary, it follows SN2 mechanism. Tertiary, mostly SN1 or elimination depending on the conditions. So, analyze the solvent, base strength and temperature carefully before solving. The carbocation stability and steric hindrance determines the pathway of any chemical reaction. Now, hack number 4. Is carbonyl compound present and reduction? Then choose the reducing agent carefully. Sodium boron hydride reduces aldehydes and ketones only. Lithium aluminum hydride reduces aldehyde, ketones, acids, esters and nitriles. Clemmensen reduction works in acidic medium. Wolff-Kishner reduction works in basic medium. Always note, hydrogen with a catalyst reduces aldehyde and ketones. Also converts nitro groups into amines. Here, selection of correct reducing agent determines the product formed. Now, moving on to hack number 5. Is oxidation happening? Then check the strength of the oxidizing agent. PCC, mild oxidation, stops at aldehyde or ketone. KMnO4 or potassium dichromate, strong oxidation, forms carboxylic acid. Hot KMnO4 may cause bond cleavage itself. Also note, alkyl benzene on reaction with KMnO4 forms benzoic acid irrespective of the length of the side chain. Thus, strength of oxidizing agent determines the final product formed. Here is your hack number 6. Is aldehyde or ketone present? First check for alpha hydrogen. If alpha hydrogen is present, aldol reaction is possible. If no alpha hydrogen in aldehyde, Cannizzaro reaction possible. If carboxylic acid with alpha hydrogen is given, then reaction with halogen follows HVZ reaction. So, Always check the presence of alpha hydrogen before assuming aldol condensation. Here's your hack number 7. Is methyl ketone present and iodine reacts with NaOH? Think haloform reaction. An yellow precipitate of iodoform confirms the presence of methyl ketone. Use this reaction to distinguish methyl ketone from other carbonyl compounds. A big note. Ethanol also forms iodoform. Coming to our hack number 8. Is benzene ring present? Check its directing effects. Phenol, amine, halogens, etc. are ortho and para directing. Nitro and carbonyl groups are meta directing. Remember, default mechanism in benzene is electrophilic substitution and the direction determines the major product formed. Now coming to hack number 9. Is aromatic amine at 0 to 5 degree given? Surely diazonium salt formation occurs. This becomes a powerful conversion hub. Think of Sandmeyer reaction, Gadamer reaction, phenol formation, halogen substitution, coupling reactions, and so on. Thus, benzene diazonium chloride opens multiple pathways. You can get the product as you wish. Coming to the final hack number 10. Is 2 products possible? Then choose the more stable one. Major product stability depends on more substituted alkenes, greater resonance stabilization, greater hyperconjugation, and when a carbocation is involved, tertiary is more stable than the secondary and primary carbocation. And in benzene derivatives, para products are often major in Friedel-Crafts reactions due to its less steric endurance. Make note, aniline ion under acidic nitration is meta-directing. Thus, stability decides the major product formed. Here's the key point. Before answering an organic conversion, quickly ask yourself, is the chain increasing? Is reduction happening? What is the degree of halide? Is the bulky base? Is alpha hydrogen present? Is there a methyl ketone group? Etc. This level of strategic thinking prevents you from making silly mistakes. So, organic chemistry is not all about memorizing every reaction. It's about recognizing the patterns and applying decision rules. Keep in mind, board reward marks for correct structural formula, proper reagents, clear reasoning keywords, and stepwise presentations. As you know, clarity gives you the marks. This is Rick Info. Hope this session was useful to you. So keep practicing, stay consistent. All the very best for your board exams. Bye.